Hello friends, I am Mr. Harshal Warade, Assistant Professor from Sanjuni College of Engineering, Kopargaon. I welcome you all for the new unit, the new part in Unit 1, that is Gauges and Design of Gauges. Let us learn Gauges and Design of Gauges today. Gauges. What is meant by gauges? Gauges are the inspection tools of rigid design without a scale, which serves to check the dimensions of manufacturing parts. Gauges do not indicate the actual value of the inspected part of the component. They are used to determine whether the part is made within the specified limits or not. We know that with the help of measuring instruments, that is conventional measurement process, it is difficult to measure each and every dimensions of the given component. But with the help of limit gauges, measurement is faster, easier, and does not require skill operator. In repetitive work, it is difficult to check the dimensions with precision instrument such as vernier caliper, micrometer, and such other instruments, which becomes much more uneconomical. So this conventional method of measurement needs skill operator and it also requires more time. So in case of mass production, interchangeability is also needed to be maintained at comparatively low cost. Hence, in order to overcome all these problems, gauges are used. Let us see the design of gauges. For design of gauges, one principle, we call it as Taylor's principle of gauge design, is used. So according to Taylor's principle of gauge design, GO gauge is designed to check the maximum metal condition or limit, that is MMC, while lower limit of hole and upper limit of shaft, that is mentioned here. No-go gauge should be designed to check minimum metal condition of limit. The GO gauge should check all related dimensions such as roundness, location, size, etc. Whereas no-go gauge should check only one element of the dimensions at a time. So let us see here. See, this is one figure which is showing us the hole and the tolerance zone for the hole, and go and no go sizes of the gauges are given here. Whereas in second figure, the second figure is for checking the shafts. See, the go gauges and no go gauges, they are also mentioned here in the figure. The tolerance zone for the shaft is also mentioned. The maximum limit for the shaft is also mentioned here. So Taylor's principle of gauge design is generally used for design of gauges. So go gauge design, it is already discussed that the go gauge should check all the possible dimensions of the component at a time in one pass. When go gauge passes through the hole, it checks the flatness, squareness, parallelism, and other such features of the component in addition to the length and width in one pass. If the corners of the component are not at right angles, then the go gauge will not enter in the hole of the component, even if the width and length are exact. In case of no-go gauge, it is already discussed that the no-go gauge should check only one dimensions of the component at a time so that the variation in the size of the component can be found easily. So it refers to the maximum limit of the hole as shown in the figure. When no-go gauge does not pass through the component, it is easier to find that the size of the component is within the limits. But it cannot be used to check the flatness, squareness, parallelism, and So procedure to solve the problems on gauge design. So here I am showing you, or I am explaining you the procedure how to solve the problems on gauge design. Following is a general procedure to solve the problems on go no go type gauge design. Step 1. Calculate the upper and lower limits of a given shaft or hole. For example, calculate upper limit and lower limit of a shaft of size 25 plus minus 0.02 mm. Then upper limit of the shaft, that is equal to basic size plus maximum limit. So that is equal to 25 plus 0.020, that is equal to 25.02 mm. Similarly, lower limit LL is equal to basic size plus minimum limit, that is 25 minus 0.02, that is equal to 24.98 mm. So this is what is the first step. But what happens if we are given the step of diameter? If the step of diameter is given with type of hole and shaft, then calculate the upper and lower limits of given shaft or hole as follows. First of all, calculate the geometric mean diameter using the step of diameter as follows. D is equal to under root D minimum multiplied by D maximum. Then second part in it, that is calculate the tolerance unit, international tolerance unit I, using following equation. So equation is given, we have to use this equation, we get the value of I which is there in micron. We can convert it into mm also. Third is calculate the fundamental deviation using given equation and then calculate upper and lower limit of hole and the shaft as follows. See, fundamental deviation for the type of shaft and type of hole, it is going to vary. So according to the given formula, we have to calculate the fundamental deviation for the shaft as well as the hole. See, for a hole, lower limit is equal to basic size plus fundamental deviation. Upper limit UL is equal to lower limit LL plus standard tolerance. Now standard tolerance is found out using tolerance grade table or formula. Then for a shaft, upper limit is equal to basic size plus fundamental deviation for the shaft. Lower limit is equal to upper limit minus standard tolerance. Standard tolerance here we are going to calculate from by using formula or using tolerance grade table, but these are basically related to shaft. Now after this there is step 2. Calculate the work tolerance and gauge maker's tolerance. Now work tolerance, the work tolerance is the difference between the upper limit and lower limit of the shaft or hole. It is necessary to specify the permissible deviation in the dimensions for gauge manufacturing. The tolerance on the gauge is allowed to cater for the degree of skill with which the gauge is being manufactured. This is known as gauge maker's tolerance or gauge tolerance. Generally, gauge maker's tolerance or gauge tolerance is taken as 10% of work tolerance. That is what I have mentioned here. Step 3. Calculate the wear allowance. Now wear allowance. Go gauges are continuously rubbed over the surface of the job, that is workpiece, to be inspected, which leads to the wear of the go gauge surfaces and reduction in their initial size. Hence there is need to provide the wear allowance on the go gauges, whereas no go gauges are not subjected to the wear of its surface. Adding wear allowance to the gauges, it will help to increase the life of the gauges in addition to the gauge in opposite direction of the wear. So as per the British standards, wear allowance is applied then the work tolerance is greater when the work tolerance is greater than 0.09 mm, and when the work tolerance is small, then there is no addition of wear allowance. So wear allowance is equal to 10% of gauge maker's tolerance. Step 4. Calculate the dimensions of go and no go gauge as follows. For a hole, Dimension of go gauge is equal to LL of hole plus wear allowance. Dimension of no go gauge is equal to upper limit of hole, that is UL of hole. For a shaft, dimension of go gauge, so that is equal to upper limit of shaft minus wear allowance, and dimension of no go gauge is equal to LL of the shaft. So in this way we are going to find out the dimensions of go and no go gauges for hole as well as the shaft. And final step is to allocate the tolerances. See, fifth step, draw the schematic representation of representation diagram of go and no go gauges. So this is a general purpose go no go gauge whose representation diagram is given here. So according to this diagram we have found out how to calculate the tolerances on go and no go gauges, how to design the go and no go gauges. Here are few references which you can refer for further reading. Thank you.